In this video, we'll be talking about what are scalars and what are vectors. So let's start with vectors. Vectors are those physical quantities which have magnitude. They must have also direction, and they should also follow their vector laws. So, for example, displacement, velocity, acceleration, force. P stands for momentum. Area, again, area is a important example. Area is also a vector quantity. To add or subtract or even multiply two vectors, we have to develop a new mathematics called vector mathematics or vector algebra. So we cannot simply add, subtract or multiply two vectors. So one more thing, division is not allowed for two vectors. Means vector A by vector B is not a defined term. Okay, vector A by vector B can't be defined. Similarly, if we look for scalars, scalars have magnitude only, they don't have direction, usually can be positive or negative. This is again an important point. Scalars can be negative as well as positive. So when they are negative, they mean some convention. For example, when we say charge is negative, charge is a scalar quantity. When we say charge is negative, I mean this is different type of charge. When temperature is negative, -5 degrees Celsius, or it's in Fahrenheit also negative. So it is below something. Potential energy can also be negative. So current has direction, but still, because it doesn't follow the vector laws, it is kicked out from the vectors community and has landed to scalars community. And we can add, subtract scalars like using simple algebraic mathematics, and we can also divide them if required, but vector division is not allowed. The first property we'll be discussing for vectors is it can be shifted parallel to its initial direction or parallel to its initial position. So let's say if this is a vector A and this is a vector B, I can draw a vector which will have same magnitude and same direction as that of A, means it is just shifted parallelly. This is vector A and this can be termed as vector B. Same length, just shifted parallelly. Not just here, I could have also done vector A, vector B. Vector B can be shifted anywhere. Just all you need to do is keep the magnitude and orientation to be same. So this is the first property of vectors. The next property of vectors is when we add two vectors, vector A plus vector B is same as vector B plus A. So if we interchange their position, the resultant will be same, or their addition will give you the same value. In the next, A plus vector B plus C whole bracket. Now we are adding B plus C and then adding it to vector A. So this will be same if we change their order. If we add A and B first, then add it with vector C. And in the same, A plus C, if we can add A and C first and then add it to B, all these will be giving the same resultant. In the next property, let A and B are two vectors. So Ka plus lambda times B will be a vector which is in the plane of A and B. K and lambda are scalars, any scalar. There are some values basically. There are some values, not just scalars, they are simply values. So we can say, let's say there is a vector A, this is a vector A, and this is vector B. If we say what is let's say A minus B, here K is 1 and lambda is B, lambda is -1. So again A minus B will also be in this plane, and A plus 2B will also be in the same plane, in the plane of paper as A and B are in this plane of paper. Similarly, 3a minus 4b or anything. Just k and lambda are any values, they can be positive, they can be negative, but any linear combination of a and b, which is ka plus lambda b, will be in the plane of vectors containing a and b. And the next property we'll be discussing, if two vectors are defined like this, a is equal to n times b, n is again some value, some integer or some fraction, some number. Okay, so a is equal to n times b. We can say a is parallel to b if n is positive, and they will be anti-parallel if n is negative. We'll explain it more by taking some examples. And the magnitude of a will be n times the magnitude of b. Okay, we have added an extra mod just to make sure if n is negative, then also the condition will be satisfied. For example, there is a vector a which is of length L. So if I'll draw in the same direction vector of length 2L, because the direction is same, I can say this vector to be 2a. I can draw a vector opposite to the given vector a of length, let's say 2L. I can say this vector to be minus 2a. I can draw a vector which is anti-parallel to a, but of length L by 3. Then this vector can be called a by 3. Again, I can create one more vector of length L, which is anti-parallel to vector a. This will be called minus a. So again, if you double the length, the vector will be doubled. If you reverse the length, an extra negative sign comes. If you 1/3 the length, the vector is divided by the same fraction, a by 3. Last one, if I draw a vector of length L in this direction, this can't be expressed in terms of a. Can't be expressed in terms of a. In terms of a vector. So all the vectors, no matter what the magnitude is, can be defined in the direction of a in terms of a. Okay, so now we'll be moving to unit vector. We'll be discussing unit vectors. A cap. A cap is also read as unit vector of vector a. So again, if I'll write b cap, this will be the unit vector of vector b. So how we get a unit vector? A unit vector, let's say this is a vector a of, let's say this is a vector a of, let's say 3 unit. 3 unit is the magnitude of vector a. 3 unit is the magnitude of vector a. So if I want a vector of unit magnitude, I will divide the vector a into 3 equal parts and take a single part of it. So this vector, which is 1/3 of vector a, has a unit magnitude and has the same direction of a. So I can say this is a cap. Again, we divided the vector a by its own magnitude, so we get a unit vector magnitude, a vector of magnitude unit, and the direction is same as that of a. Another example, let's say there is a vector b, and the magnitude of b is now nothing but simply b without any bar. So what will be b cap? As the magnitude is b, we have to divide vector into b parts. So b vector, when divided into b parts, will give you a vector of magnitude 1 parallel to b. So a cap is nothing but a vector along vector a having magnitude 1. B cap is nothing but a vector parallel to b having a magnitude 1. We have defined three fundamental unit vectors I, j, k along three different mutually perpendicular directions x, y and z. In this part we'll be looking at why we have to define unit vectors at all. So the best explanation is, if we have defined a vector a cap, then which is along vector a obviously, then we can define any vector which is along vector a in the terms of n into a cap. N is the magnitude of that vector. For example, I have a unit, I have vector of magnitude 5. Now I want to define a vector which is parallel to this but has a magnitude 7. So what I'll do, I'll say B is nothing but 7a cap. How? 7 vector A by magnitude of vector A, which is nothing but 5. So it is nothing but 7a cap. Okay. Now if I want to define a vector which is opposite to this and has a 3 unit, so I'll say minus 3a cap. Okay. So that is why we have to define cap, because now any vectors which is along A can be defined in the terms of a cap.